Okay, so today we continue for example of galvanic cell. Okay, so this is an example of galvanic cell, or we can call as a voltage cell. Okay, or Daniel cell. So actually this is the real picture. Okay, so if you can see here, if you want to draw, okay, now I will teach you how to draw the diagram of the voltage cell. So this one, okay, if they are real one, okay, this is beaker, and then it has an electrode, okay, that has a voltmeter, and they have salt bridge here. Okay, so if you want to draw this one, so you cannot draw like this. Okay, you must draw in 2D structure only. Okay, so means that you put a beaker and then another one beaker. Okay, and then you draw the electrode. Okay, so one of the electrode and the another electrode. Okay, and then for example, if the question give you this is anode. Okay, so this is a zinc electrode, and then this is a cathode. Okay, for example, so this is your copper, and then make sure your wire must be connected like this. Okay, and then you put the voltmeter. Okay, make sure voltmeter you must shows the needles. Okay, jarum dia maksud dia reflect, dia must be reflect, and then you must label voltmeter. Okay, and then make sure there has a salt bridge here. Okay, put the salt bridge. Okay, so what else that you have to put? Okay, adalah, okay, here you can draw the solution here. Okay, put the solution. Okay, make sure you have to look at to the question. If the question give, for example, zinc, so zinc sulfate. Okay, okay, put the phase aqueous, and then the other side is a copper, so means that they have copper sulfate. Okay, aqueous. Okay, then you have to know that they have the uh, movement of the electron before and after. So electron before and after. Okay, and then you label the salt bridge. For example, if you use the salt bridge of KCl, so Cl minus, okay, we go to this one, K plus we go to this one. So this is an example diagram for voltage cell. Okay, you must draw like this. Okay. Okay, so make sure, okay, everything this one is about like 3 marks lah. Okay. Right now we try go for, okay, if what happen if there has no salt bridge here. So for this one, okay, actually you have to put the salt bridge. What happen if there has no salt bridge here? So for this one, okay, for anode, okay, it occur the oxidation, right? So zinc will come to zinc to positive, okay, plus the electron. Okay, so it means that zinc 2 plus will enter to the solution. Okay, bila dia masuk dalam solution, sebab dia kan bercharge positif. Bila dia charge positif, dia akan ada excess of positive charge. Okay, bila banyak sangat positive charge dekat dalam solution ni, so it means that it's not unstable. So kalau tak ada salt bridge, okay, why for cathode, if a cathode, okay, copper 2 plus, okay, plus dia akan gain the electron. Okay, dia akan dapat 2 electron become copper solid. So dia menyebabkan, okay, copper 2 plus ion leave the solution. Okay, menyebabkan yang ni sebab dah jadi copper solid, right? So means that this causing an overall excess of negative charge. Okay, dia akan ada terlebih negative charge. Yang ni dia akan terlebih positive charge. So bila terlebih ni, okay, dia akan menyebabkan reaction kita akan jadi tak stable. So dia boleh jadi stop. So what happen? Okay, so you have to, okay, bila dia ada excess charge ni, so kita kata kita boleh reducekan dengan menggunakan salt bridge. Because the salt bridge here, you can see here dia ada K, salt bridge kita ada K dengan Cl. So KCl ni dia ada ion yang akan neutral balik kan, yang ni kalau ni ada positif kan, banyak positif, so neutralize dia adalah negative charge. So siapa negative charge in this case? So dia Cl minus lah. Okay, kalau yang ni pula dia adalah copper tu positif, dia akan ambil kan, dia berkurang. So bila maksudnya dia akan copper to positif ni kurang positif kat sini. So banyak negatif charge. So yang ni pula K plus pula yang akan masuk dekat sini, enter dekat sini. Ci minus yang akan masuk kat sini lah. Okay, jadi dengan adanya salt bridge, so this kata-kata dia boleh neutralize. Okay. Okay, so now I go for exercise. Okay, write the half equation and overall equation for the following solution. Okay, for example, okay, as you all know that, okay, you remember about the anodes, ANOX, okay, anodes occur oxidation, and then cathode always remember red cat. Okay, reduction occur at cathode. Okay. So nickel, okay, so occur as a, okay, so nickel will become, make sure you put the phase, okay. So nickel become nickel to positive, so nickel to positive, and you have to balance the electron, plus 2 electron. Okay, this one become nickel equals lah, okay. Y for cathode, which is a Ag, so Ag means that it occur reduction. Okay, so Ag plus aqueous, okay, plus the electron will become Ag solid. Okay, so what you have to do is you have to write the overall equation. So how you do the overall equation? So you can see here your equation is a just only one electron. So this means that you have to balance the equation. Okay, this one you have to times everything. So you akan dapat 2Ag plus 2 electron to become 2Ag solid. Okay, so what you have to do is, okay, you put the line, okay, like this. Okay, then okay, which one that you can cancel? So 2 electron can cancel with 2 electron. Okay, next you put the you punya right side, you punya return, and you punya sorry, left side is your punya return, and your punya right side is your product. Okay, so you draw all this thing, nickel solid plus, okay, 2Ag plus aqueous, okay, and then you produce this one, nickel to positive, aqueous plus 2Ag solid. Okay, so this is your answer. Okay, next example. Okay, I will go for, okay, the next one you go for okay, barium. Okay, I go for one. Okay, this one you do it yourself, okay, as your task to remember to do it. Okay, for number 4 I will do for this one example. Okay, so you know barium occur at anode, so barium solid. Okay, so we'll oxidize, okay, they will be oxidized to become barium 2 positive aqueous. Okay, so balance dengan 2 electron. So 2 tambah 2 jadi kosong lah kan, 2 tolak dengan 2 electron, tambah dengan 2 negatif kan electron, so jadi kosong lah, so charge dia balance. Okay, while sodium is occur at cathode, so cathode occur apa, dia ada occur Na kita tahu kan, Na is Na plus. Okay, sebab dia punya stable dia. Okay, so dia akan occur reduction. Okay, means that dia gain the electron, okay, to become Na solid. Okay, so you can see here the same thing here, you darab dengan 2 to balance the equation. So kat sini semua akan jadi 2. So lepas tu you boleh cancel lah yang ini, saya buat cara cepat, yang ni cancel dengan yang ni. So you akan terus dapat, okay, so kat sini barium solid plus Na plus, sorry 2 kan, kat sini sebab darab 2, aqueous produce barium to positive aqueous plus 2 Na solid. So this is your overall equation. Okay, so make sure you know how to do the overall equation. Okay, so next we go for the, okay, for cell notation. Okay, so what is a cell notation? So cell notation is a representing combination of reduction half cell notation and oxidation half cell notation. Okay, macam mana nak ingat dia combination ni? So kita akan buat dia sebagai nama dia ABC. Okay, ABC bukan air batu campur ya. ABC adalah refer kepada, okay, anode, okay, B bridge, C is a cathode. Okay, so okay, ini cell notation. Cell notation ni kita combination of reduction dengan oxidation. Okay, kalau yang ni awak dah ada dia punya overall equation. So, kita tahu zinc become zinc 2 positive, copper 2 positive become copper solid. So, you dah tahu dah zinc dekat zinc 2 positive dia occur oxidation. Copper 2 positive jadi copper kita tahu kan dia reduce dia punya oxidation number. So, dia jadi reduction. Dekat mana you kena lukis? Okay, A, B, C. So, A means anode. Okay, so you buat dulu side yang belah oxidation. Belah sini is anode. Okay, maksudnya zinc. Okay, you letak dia punya face dia. And then, okay, you ada dia punya satu ni. Kita buat macam satu macam pagar ni. Okay, menunjukkan dia ada terpisah lah. Dia become zinc, then dia become zinc 2 positive. Zinc 2 positive. And then, kalau dalam soalan dia tak bagi apa-apa, standard dia, you kena tahu kalau dia standard, dia adalah aqueous. Okay, dia bentuk aqueous dan dia adalah rujuk kepada 1.0 molar. Okay, lepas tu kita letak dua line ni menunjukkan, dua line ni maksudnya dia menunjukkan dia adalah short bridge. Okay, ini dia punya cara nak tulis lah. Okay, lepas tu kita letak C. C ni refer kepada yang berlaku dekat cathode. So, means that, okay, copper 2 positive become copper. So, you letak copper 2 positive aqueous 1.0 molar. Standard dia 1.0 molar. Kalau dia tak tulis dalam soalan, so you kena tahu dia adalah 1.0 molar. So, become copper solid. Okay. Alright. So, for example, if you do the cell notation that involving the gas. Okay, so gas for example here. Okay, gas dia lain sikit sebab dia ada kat sini you akan nampak dia ada hydrogen gas. Okey, dia masuk dia dia punya standard dia adalah bila gas kita kata dia akan menyebabkan pressure. So pressure dia dalam 1 atm. Okey, berlaku dekat anode lah. Okey, while cathode dia ada copper. Okey, kita tahu dia ni berlaku reduction, yang ni berlaku oxidation. So macam mana nak tulis dia? So, you kena tahu hydrogen gas ni bila dia masuk, okay, H2 gas, okay, dia akan produce, okay, kita tahu dia akan dapat, bila dia masuk kat sini, dia masuk ni, nanti kita cerita lebih lagi yang ni, okay. So, dia akan dapat H plus, aqueous, okay, plus, okay, with, okay, 2 electron. Because it's a 2 hydrogen, so means that kita kena balance 2 lah. 2H plus, so tambah dengan 2 elektron untuk balancekan dia punya elektron dia, dia punya charge kan. Okey, kalau dekat cathode always ingat red cat, so cathode copper. So copper ni kita tahu dia ion dia adalah copper 2 positive. So dia akan gain 2 elektron, okay, to become copper solid. Okay, so this one kita akan buat dia, yang ni boleh balance dia tolak. Okay, so hydrogen gas akan produce copper 2 positive aqueous. Okay, produce with 2H plus aqueous plus copper solid. Okay, this is your overall equation. Okay, so how you want to draw the cell notation? So the same thing you write as A, B, C. Okay, so A, B, C awak jangan lupa. So, kena letak B as you punya short bridge. Okay, untuk cell notation, untuk yang involve the gas, you kena letak satu dia punya ni adalah dekat sini, dia ada satu kat sini bawah ni. Kena perasan dia ada satu nama dia, catalyst dia. Kita pakai platinum. Okay, PT. So, dekat dia tak boleh berdiri macam tu je, okey, untuk hidrogen, untuk yang melibatkan gas. So dia ada satu bantuan kita panggil PT. PT ni sebagai dia punya catalyst dia lah, okey, untuk bantu dia proses untuk dia berlaku oxidation. So kita buat proses the H2. So H2 become, kita tengok kat sini H2 jadi H plus kan. So H2 awak buat, okey. Okey, kita tahu phase dia gas. Okey, so kita tahu dia standard dia 1 atm. Alright, lepas tu tutup bracket. Then you put, okay, H2 become H plus. So kita akan tarik dia satu lagi. So H plus, okay, dia akan jadi aqueous. Okay, standard dia adalah 1 molar. Kena letak dia punya concentration dia. Okay. Okay, tapi kalau dia tak ada bagi tahu, so you assume kat sini dia adalah 1 molar lah. Okay, 1 molar. Okay, bridge dah buat. Okay, dan kita pergi ke copper 2 positive. Copper 2 positive aqueous. Okay, become copper solid. Okay, sorry, copper aqueous kita letak 1 molar kat sini. Sorry, koma koma. 1 molar. Okay, slash copper solid. Okay, so this is your cell notation lah. Okay.